This is not a sponsored video. I remember learning how to factor binomials for the first time. I was so frustrated by the process. I asked a teacher, when am I ever going to use this? I didn't really care about the answer. I was just trying to stall the teacher so they wouldn't get to assigning the homework. The teacher shrugged and continued the lesson. After a bit of insistence from the class, the teacher eventually responded with something like, "You may not use this specific thing, but in math class we are building problem-solving skills." I scored horribly on the assignment. Because the questions on the test were multiple choice, I was able to check my answer, and through process of elimination, I did reasonably well. It took another 15 plus years for me to discover some of the applications, though. What I didn't know at the time is that my teacher had insights I simply couldn't comprehend. It's like teaching someone to count. Do you spend time telling them about 1,000 before they are showing recognition with 1, 2, and 3? That would be absurd. They may understand there are more or less, but to comprehend how much takes time and effort to develop. Math application is the same way. We can only see the application once we've spent the time developing the skills to recognize it. What might not be obvious is that video games help develop problem-solving skills. What's bizarre and unexpected is that they do so without calling attention to the problem-solving itself. A lot of people think this means math isn't involved in video games, but it's quite the opposite. Oftentimes, these problem-solving skills align with mathematical concepts. The way people play games is close to the way mathematicians explore mathematics. I think most would be surprised to hear this. Because video games offer multiple ways to approach the problem, I think it creates a different feel from what we have come to expect from math. However, most people never get to a level of mathematics that allows for exploration. This is because the math consumed today has been developed for centuries. Gamers are given freedom to explore with a set of tools to accomplish a goal. These tools can be weapons or a way to move around, or even environmental elements. Working within the game's mechanics, the gamer has freedom to move around however they decide. Those that spend significant time in playing the game are likely to become very familiar with the limitations of these tools. They may even break it down far enough to discover why they should favor a specific type of tool over another. Or, given a specific mechanic, why it may require a specific type of movement. Mathematicians are given freedom to explore within a set of tools to accomplish a goal. The tools mathematicians are working with are logic, counting, geometry, and data. Most branches of mathematics have been developed based on discoveries of how to utilize tools effectively. This is a similar process to what gamers do when looking for limitations within gameplay. The aha moments of video games is a major driver to continue to play. Mathematics has aha moments too. A lot of them require significant dedication before the aha. This can make the aha more rewarding, though. All of this is to say that you are likely doing more mathematics than you realize when you play video games. It's presented differently, but there are significant parallels between playing video games and creating/discovering mathematics.